Hello, everybody. I've made this video so that we can go through the flashcards for Saturday. The way I teach glaucoma is there's a set of common changes at the back of the eye, and then there are more specific changes depending on what's happening with the glaucoma type, mainly at the front of the eye. So this is the first one. So here you can see that there is a big cup, right? So this is the classic change of glaucoma, and notice the bowing, the posterior bowing of the lamina cribrosa, and the way that the optic nerve is thin and narrow. That's because of the loss of axons. I'm sure that the registrars will be able to tell you quite a lot about the nerve fiber loss that leads to this. Um, so Glaucoma kills all the nerve fibers, particularly at the outer edge of the optic disc. There are several mechanisms for this. So one of these is physical compression because of the high intraocular pressure. And the other one is ischemia or poor blood flow, which deprives the nerve fibers of oxygen and nutrients, causing nerve fiber death and then cupping. It's probably a combination of these. The next slide, here we go, is this. So here we've got the optic nerve head again. We've got the choroid here. We've got the remains of the retina here. We aren't seeing the cup very well. We've got the lamina cribrosa here, but now the optic nerve has got a bunch of holes in it. And this is cavernous optic atrophy. And if you're clever, of Schnabel. Um, so again, this is advanced optic nerve degeneration due to ischemia and due to pressure. The nerve fibers are dying and leaving the surrounding astrocytic and connective tissue, which is caused by, which leaves the holes. Okay. And then we move to the front of the eye. So this is one of the most common causes of glaucoma, and this is angle closure glaucoma due to neovascularization. So if we look here, you'll be able to see that the iris is adherent to the posterior part of the retina. So here are some landmarks. So this is the trabecular meshwork and the canal of Schlemm and the scleral spur. This is the muscle fibers of the ciliary body. And we can see that the normal iris vessels have got wee cuffs around them. But here we've got the posterior iris adherent to the trabecular meshwork and blocking it off, so there can be no drainage. We can't tell what is causing the new vessels here. We can see that there's like flat iris, ironing board iris, and we can see some of the vessels have got a suggestion maybe that they aren't well cuffed. But basically, this is angle closure glaucoma blocking off the trabecular meshwork. So the commonest causes usually are proliferative diabetic retinopathy, central vein occlusion, and ocular ischemia from other causes. Okay, let's move on to the next slide. Okay, so in this next pair of slides, we're going to look at the difference between phacolytic and phacoanaphylactic glaucoma. Just moving on here, I've circled that adhesion. All right, so this is a close-up of the lens, and the lens has basically lost its capsule. And so we have a type 4 immune reaction where we've got the non-specific kind of inflammatory cells here, but in particular here we've got a granulomatous reaction. So this is phacoanaphylaxis. It is caused by mature cataract, and then an immune reaction where the eye sees its own lens protein as foreign. Trauma, surgery can release the immune response. So we call it phacoanaphylaxis. It's a type 4 immune reaction that is cell mediated. And all this inflammatory debris then goes and blocks the trabecular meshwork, causing glaucoma. Now, that is in contrast to the other lens type of glaucoma, which is this one here. So this is phacolytic glaucoma, as it suggests. The lens becomes lytic. We've got an open angle here with a corrugated iris, and the trabecular meshwork is here actually, with the canal of Schlemm and the scleral spur, ciliary body, and now we've got an intact lens capsule, but like everything's leaked out of it, and it gets taken up by macrophages. This protein, it doesn't cause a type 4 immune reaction. What they do is they go to the trabecular meshwork and they physically just clog it up, block the drain. Right, the next one is a very interesting cause of glaucoma, and that is pseudo exfoliation, sometimes um, uh, sometimes shortened to its initials. The pseudo exfoliation syndrome is sorry, we're just sorting this out a bit. The pseudo exfoliation syndrome is a whole body condition, which is a genetically inherited condition. They're missing an enzyme for forming and maintaining elastic fibers by cross-linking collagen and elastin. And so it gives rise to changes through the body, heart, kidneys, liver, lungs, but it only causes harm within the eye. So pseudoexfoliation syndrome, PXF, these abnormal proteins are produced. They form these lovely little dendritic structures on the front of the lens, which we can see here. This is the lens, but also on the back of the iris, and if it's really severe, on the ciliary body as well. And it's this physical protein that blocks off the trabecular meshwork. Okay, the next slide. All right, so this is a post-traumatic eye. Lots of things happen in post-traumatic eyes. Let's have a little look at what's happening here. So we've got the trabecular meshwork here. We've got the iris here, and the iris root has torn away from the back of the sclera here. It's got ciliary bodies here. There's lots of hemorrhage. So there's several mechanisms for glaucoma here. The first is angle recession glaucoma. So this usually becomes evident about 6 months after this change, where the eye started recovering, but this angle never actually heals. So there's a pathological split between the ciliary body fibers here, and then there's a change in the shape of the globe, and the um, and the sorry and the fluid in the anterior chamber can be forced into this gap, which maintains it. And I'm not quite sure how it mechanically disrupts the trabecular meshwork, but it does. Okay, let's think about other causes. So sometimes we can get either direct red cells or macrophages here with hemorrhage in them, which can also block up the angle. I think I've got a case of that later. All right, let's have a look at the next one. Okay, so this next one is showing the angle 3 years later. Okay, and you can see that a lot of the acute changes have settled down. We've got the trabecular meshwork and the canal of Schlemm here. So the arrow is pointing to where the iris root should be. but in fact it has recessed. So angle recession is relatively common after trauma, and this is the scleral spur here, and so we should have iris attached kind of here, but it's not. Let's have a look at the next one. All right, so this is the other consequence of trauma to the eye, where we can see macrophages which are loaded with hemosiderin, and they are now in the trabecular meshwork. The arrow is pointing to broken down, possibly red cells, sometimes called erythrocyte ghost cells, and it occurs in the context of chronic vitreous hemorrhage of any reason. The next case is this one here. So it's pretty obvious something's going very badly wrong here in the trabecular meshwork. The trabecular meshwork is full of pigment, and there are loads and loads of macrophages really densely with pigment. So the most common cause of dense pigment in the iris that is like this is a melanoma-lytic glaucoma. So the melanoma in the eye undergoes necrosis, macrophages fill up, and it fills up the trabecular meshwork. You can non-specifically see light pigment in the trabecular meshwork, and in primary open-angle glaucoma, there is an increased amount of pigment as well. Okay, let's have a look at the next one. So hopefully the students will be able to tell you about this. So this is pigment dispersion syndrome, where pigment rubs off the back of the iris and floats into the eye, clogging the drainage system. It is another cause of pigment in the trabecular meshwork. So this is an iris which has been transilluminated posteriorly, and you can see this ring of pigment loss where it's rubbed off. And then this is a very high power view of pigment accumulating in the angle. They just go between the trabecular plates and are phagocytized by the endothelium or by macrophages. And then this isn't good for the trabecular endothelial cells, and they die. This isn't such a great photo. Might have to change it. Right, the next one. Okay, so the next one is epithelial downgrowth syndrome. So imagine that there has been some kind of surgery and the squamous cells have got implanted here. They do what squamous cells do and start to grow like a membrane. But of course, if you've got squamous cells that are growing over the trabecular meshwork, the fluid can't get through. So this is epithelial downgrowth glaucoma. The next one is this one here, which is interesting. So the students, but possibly not you, will have heard of iridocorneal endothelial syndrome, or ICE syndrome. So this is an abnormality in Descemet's membrane. So here we can see Descemet's membrane with the endothelial cells, and it has grown over here onto the front of the iris and adhered to the iris to the posterior cornea. So we can see Descemet's going along here like normal, and then we've got adherent iris, and it's growing on the front of the iris here. It's pinched off a little nodule of iris stroma here as the endothelium has grown. After the initial growth, it contracts and pulls the iris down. Okay, so the last one is the other kind of glaucoma that we get, not acquired glaucoma, but we can also get glaucoma that is congenital, and often in anterior eye anomalies, there is no trabecular meshwork. So here we've got this this ciliary body, this short stubby iris, and we don't have any trabecular meshwork formed. And that is the end of the glaucoma slides. So I'm going to just go to here and I'm going to stop recording.